Hello everyone and welcome into yet another live stream, and yes, early stream indeed. Hi, early stream indeed, because, we've been streaming late recently, and many people mentioned that they would rather see streams at different times, so here I am. We're streaming at an earlier time. Y'all are welcome. Yeah, I haven't slept tonight, but that's happens. I'm still awake from the last stream. Yeah, there we go. Yeah, see? Instant no. Now let me just set up everything, because of course I'm starting as unprepared as always. What are you doing today? Well, you won't believe it. Yeah, yeah, this is going to sound crazy, but we're doing organic chemistry. Hold on. It's screwed up again. There we go. This one. There we go. This one. There. Neat. That's like me for... I'm still awake from last stream, yeah. To be fair, it hasn't been that long. It's been like, what, 6 hours, I think? I think it was like around 6 hours. But it is a different day. Because last stream started a bit late. This one is a bit early. For European time, obviously. For Americans, this is still technically the same day. Although it won't be for long. Whereas I won't be here, probably should be studying. Then I'll stay for a few minutes. Hey, you can go, it's fine, it's fine. These do literally happen every day. So, you won't be missing out on anything exclusive. Now, wait, map. Yes, that's just the whole thing. Now, we've been at acids and bases for the past 2 streams. That's nice. Yeah, I don't want to be holding any of you back, okay? If you want to study, if you have to study, go study. It's important. As I mentioned, these do happen every day. You won't really miss out on anything exclusive, so it's fine. Hold on, predicting the outcome of acid with reaction. I'm pretty certain that's the one we finished, right? I think so. Okay, so pKa value, for those who remember, it's the what's kind of linked to the equilibrium. Where is it? That's where it is. Right here it says equal, but that's only because that's what's said in the book. In reality, it will be this. So I guess we should switch it up. Right here, actually, even lower, we will have PEQ, which is equal to 10 to the power of delta pKa. The reason why delta is there is, not delta, the reason why 10 is there is that this, if you remember, pKa is the relative acidity and it's negative log of Ka. So log, in order to inverse log, we need 10 to the power, and then delta brings just difference in pKa. Yeah, the point is, this tells us how the reaction should go which way. Or rather, the tendency of reaction to go either way, right? Now, first, we need to identify the acid spaces on the side of the equation. On the left side, the acid is, of course, acetic acid. On the right side is methyl ammonium. The specific pKa values for these acids are not on our very generalized pKa table, but are given in the figure above. Without performing any calculations, you should be able to see that this equilibrium lies far to the right-hand side. Okay, so it basically will... this one is the stronger acid, which means that it will tend to go this way because it wants to be more stable. Acetic acid is weird. It really is. Acetic, because it's acetic. It's annoying to pronounce. I'm already having trouble pronouncing stuff like water and throwing in acetic acid there. So KEQ is a very large number, much greater than 1, and the equilibrium lies far to the right-hand side of the equation. Just we have predicted, if you had just wanted to approximate an answer without bothering to look for a calculator, you could have just noted the difference in pKa values is approximately 6, so the equilibrium constant should be put somewhere in order 10 to the 6 or 1 million. Using pKa table this way and making functional group-based pKa approximations for molecules for which we don't have exact values, we can easily estimate extent which a given acid-base reaction will proceed. Okay, so this is equal to 10 to the power pKa, and yeah, okay. So if it's really large, it goes this way. If it's really small, it goes this way. Seems simple enough. It's like stating there's H2O in my water. No, it's acetic acid. It's It's a kind. Like sulfuric and stuff like these, you know. Yeah, this one's a bit longer. Let's see, was it factors that determine acid strength? Okay, but this would be important. First, we will focus on individual atoms. So, hold on, let me just note down right here. I don't like just how varied the text size is. That's what I have to do in order to make it actually visible, pun intended. What determines the strength of acid? We'll have... there we go. So, first we'll focus on individual atoms and think about trend-associated position of an element on the periodic table. We'll use as our first models the simple organic compound ethane, methylamine, and ethanol, but the concepts apply equally to more complex biomolecules such as the chains of alanine, lysine, and serine. Alright, so we can see a clear trend in acidity. Okay, let's try to see it for ourselves. We have stronger base, stronger acid. So, the really strong acids, because I'm right here, it removed... I'm sorry? So right here, it... Are these bonds breaking? What? I have to be reading this wrong, right? Also, I want to ask you a question before, for the bullish question, but why did people leave? It's not a weird question. Happy, in comparison to what you post daily, this is a pretty mild question. The reason why people left is because she didn't like the debating channel. Wait, these wasn't bonds breaking. I am so confused by this image. I think they are. I mean, they're not noted down. Some of them are. Which means... No, I can't think of a single conclusion based on this. I'm no. As we move from left to right along the second row of periodic table, from carbon, nitrogen to oxygen. Oh, these are all the same. Wait, no, they're not. As we move from left to right along the second row of periodic table, from carbon to nitrogen to oxygen, the key to understanding this trend is to consider the hypothetical conjugate base in each case. Rhymes. The more stable, weaker the conjugate base, the stronger the acid. Look at where the negative charge ends up in each conjugate base. In ethyl anion, the negative charge is borne by carbon. While in the methylamine anion, the ethoxide anion, the chain that charges are located on the fudge. This is awful. I hate this so much. I don't understand how organic acid strength works. Could you explain it? I don't either. I don't get it either yet. Funny you should ask, Vignesh, because I don't know how it works either, so we're kind of trying to... This is an awful sentence. How is this supposed to set us up for electricity? No, oh, it isn't. Has nothing to do with electricity, actually. Funny enough. The key to understanding this trend, okay. This sentence. It's gonna take a couple of tries to get through. In the ethyl anion, the negative charge is borne by carbon, while in the methylamine anion, the exodide anion, the charges are... and exodide anion, the charges are located on nitrogen and oxygen respectively. Okay. In ethyl anion, which is... Okay, ethyl. This textbook requires me to know a lot of things, which I don't. Ethyl group, so it's... Okay, this is ethyl group. So it's basically like this. Except that right here we have... No, wait, it's this. Here's the... Okay. Ethyl. Got it. Neat. Ethoxide ion. Ethoxide anion. Oh, gee. This is fun. So, simple. It's simple stuff. It's simple stuff. In ethyl anion, the negative charge is borne by carbon. Yes, this one. While in the methylamine anion and exodide ethoxide anion, the charges are located on nitrogen and oxygen, respectively. Remember the periodic trend in electronegativity? It also increases as we move from left to right along the row, meaning that oxygen is the most electronegative of the three and the carbon is the least. The more electronegative an atom, the better it is to bear is able to bear a negative charge. Thus, the ethoxide anion is the more stable. This one. Lowest energy, least basic of the three conjugate bases, and the ethyl anion is the least stable, highest energy, most basic. Alkyl is alkaline hydrogen atom, right? I have no idea. I'm not a chemist. Are you going to work in a video with Scrap Scientist's channel, or does he not want that? I am, but the progress on this, I don't know, it's just like... I feel bad, honestly. I feel like I'm using Scrap. Well, because the video didn't blow up. It's not doing too badly. It's not doing too well either. You have to remember, I spent 2 weeks on it. Yeah, 2 weeks. Okay, well, it's not doing too great either, right? Okay. 2k views. Yeah. The What is Map video, I think, got 3,000 first days. They have electronegativity values. We had them. I think we did, at least. Alright. So, the more electronegative, the more acidic? Wait, hold on. No. Yes? Yeah. No. 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 Yeah, no. Have to wait for Mr. Green to give you a shout out. Ah, that's a great strategy. Just wait for some... that's what I gotta do. I just need to wait for someone popular to get me going. No, it's fine. We'll just fake it till we make it, okay? That's the plan. We'll just keep on making videos until it works. Acetic acid is the most acidic acid. No, I said sulfuric because if I do remember correctly, -10 was the lowest they mentioned, and -10 is what sulfuric acid has. Your consistency is remarkable. Thank you. Well, actually, I just realized that's a compliment. A consistency, I could be consistently awful, actually, and I would still be extremely consistent. Still, thank you. I'm gonna assume the best. I'm gonna assume the best. Thank you. Yeah, so we just have to keep on going. This time, formic acid is the most acidic acid, right? I have no idea. I'm not a chemist. I'm just here to learn. This is like college grade chemistry so far, and I'm already stuck on it. I am really awful when it comes to chemistry. Ah. Lower antimonic is the strongest acid ever discovered. Yeah, let's just... How about we just first cover our bases? And pun intended, by the way, cover our bases. I'm really funny that way. Cover our bases and get through this first. Okay. The more stable, weaker, the conjugate base, the stronger the acid. Yes. And I remember that from the previous chapter. Or previous 2 chapters ago, actually, I think it was. So the weaker the conjugate base, the stronger the acid. And so the more electronegative the conjugate base atom, which is left with the negative charge, the better, because electronegative atoms can... Okay, the more electronegative the atom that's left with the negative charge when donated, the strong acid, because electronegative can bear negative charge. better. Cheating. Chemistry, my opposite of my favorite. I much prefer data analysis, harder math. It's I mean, it's like a, it's love-hate relation, you know, you just got, it's quirky. Hydrofluoric is as curious one as a pair with reviews though, right? I have no idea. Don't ask me, I don't know. I know about as much as any of you, honestly. By looking at the pKa values for the appropriate conjugate acids, we know that ammonia is more basic than water. Oxygen, as the more electronegative element, holds more tightly to its lone pair than nitrogen. The nitrogen lone pair therefore is likely to break away and form a new bond to a proton. It is, in other words, more basic. Once again, a more reactive, stronger conjugate base means a less reactive, weaker conjugate acid. Okay. But I'm protons positive. Also, I had know the atomic number of people with protons. So how can it be donated? The hydrogen. As you can see, all of those are donating hydrogen. So these are the acid versions, and the bases are missing a hydrogen. And hydrogen is just a single proton. So basically, the hydrogen goes away and leaves behind an electron. Open Khan Academy or something. No. We can get through this. We're not cowards. We're brave. We can get through this thing. I shall not be defeated by a piece of text. I should not be defeated by just a couple of paragraphs. We're getting through this whenever my mental health likes it or not. We'll get through this. Okay. The nitrogen lone pair, therefore, is the more likely to break away. Proton is one boy space. Okay. Once again, when moving vertically within a given column of the periodic table, we again observe a clear periodic trend in acidity. This is the best illustrated with the halides. Basicity. Halides basicity, like electronegativity, increases as we move up the column. Okay, so which means that the strongest possible, the best atom for the acid would be, like if you imagine this as a periodic table, would be right here, I think. Depends on, I think it would be right here. Increases as we move down the column. In order to make sense of this trend, we also consider stability of conjugate bases. Get a reach from square one to catch up. Be right back. I have no idea what I'm reading. Where does the electron go to? Large atoms donate protons. No idea to the second part of that question, but first one, the electron stays behind, as you can see. This minus right here. It's the electron staying behind. Well, this dot to be exact. So then we have, I remember there are electronegative values for fluorine 2.1 hydrogen. I don't remember anything. I don't know what I'm doing. Conversely, acidity has okay. Because fluorine is the most electronegative halogen element, we might expect fluoride to also be the least basic halogen ion. But in fact, it is the least stable and the most basic. It turns out that when moving vertically in the periodic table, the size of the atom trumps its electronegativity with regard to basicity. The atomic radius of iodine is approximately twice that of fluorine. So in iodine ion, the negative charge is spread out over a significantly larger volume. Okay. The larger the atom, also the better, because the negative charge can be more spread out. Oh, so it's basically like how well can they handle negative charges? If they can handle them well. So from the main question, I just got curious. That's what the chat is for. Hi, the soda, by the way. Clueless Make It Dark. Oh, mate, you clearly haven't seen many of these streams. Every single one of these lessons is Clueless Make It. It's been 3 weeks, by the way. Around 3 weeks since we started these everyday research streams. Child checkups have been going for over a year, but you know, the everyday research, that's only been for a couple of weeks, and oh boy, it's fun. It's doing wonders for my mental health. What? Lumber Kid? It's Makita. It's a different name. charges for annoying make it, obviously. There are better ways to annoy me. Just ask questions. Asking questions is not that annoying. No, I wouldn't even... I don't think asking questions is annoying. I mean, there are certain exceptions, obviously. There are certain questions which are, well, curious. But most questions are fun to answer. This illustrates the fundamental concept in organic chemistry that's important enough to put it in red. Oh! We're putting it in red. That's really important. They're putting it in red. Electrostatic charges, when they're positive or negative, are more stable when they are spread out than when they are confined in one atom. Red. How do you pick red color for this? This is how you pick a red. Hold on, let me just save black later. There we go. Red. Electrostatic charges are more stable when they are spread out than they are atom. Makes sense. I'm still doing science, 5 AM. Yeah, I'm researching stuff. Chemistry, organic stuff. They're curious. Now I wonder what type of questions are those. Well, there are certain questions which are like made to annoy. We'll see this idea expressed again and again throughout our study of organic chemistry in many different contexts. For now, the concept is applied only to the influence of atomic radius on anion stability. Because fluoride is the least stable, most basic, of the halide conjugate bases, HF hydrogen fluoride is the least acidic of halo acids, only slightly stronger than acetic acid, HI. Okay. More importantly to the study of biological organic chemistry, this trend tells us that thiols are more acidic than alcohols. The pKa of thiol group on the cysteine side chain, jeez, they really like their names, you know? Fun. For example, it's approximately 8.3, while pKa for hydroxyl on the center chain is on order of 17. Okay, this is a phenomenal graphic and I love it. Selected images in unsupported format. You're an unsupported format. You bring really unsupported for my formats, you know? There. Fixed. Support that. Ah, got him. So now it was in the screen. Yeah. Tomorrow's day 50. Hopefully we found make it on the science grind day 500. I don't know what to do for 450, honestly. Yeah, 500 is in over a month. Oh gee, what am I going to do for 500? Oh, I have no clue. I have to think of something. No, damn it, I have no idea what I'm going to do for 500. Okay. Resonance effect. What is the differences in acidity and basic ability in groups with the... Now it's time to think about how the structure of different organic groups contributes their relative acidity or basicity, even when we are talking about the same element acting as a proton donor acceptor. The first model pair we will consider as ethanol and acetic acid, but the conclusions we will reach will be equally valid for all alcohol and carboxylic acid groups. Okay. Face cam. We already did the face cam. We need something new. Something exciting. pKa values of ethanol and acetic acid are different when it comes to acid, so much more acidic than alcohol. As before, we begin by considering conjugate bases. Okay, so why is there a basic channel but not acidic channel? I love this fun. I love it so much. Just that was a really good one. Look on the stream, by the way. That was a 10 out of 10. All right. In both species, the negative charge on the conjugate base is held by an oxygen, so periodic trends cannot be invoked. For acetic acid, however, there is a key difference. A resonance contributor can be drawn in which the negative charge is localized on the second oxygen of the group. Two resonance form. Oh my goodness, I'm gonna have to reread all this again because it's so many fun words in there. In both species, the negative charge on the conjugate base is held by an oxygen, so periodic trends cannot be invoked. Okay. negative charge on the conjugate base is held by an oxygen. So we have acid. There we go. And we have the... Oh, is it because the... Wait, hold on. Isn't this because the electron is in between the two? The text in red thing. It's like a pretty simple, isn't it? Am I right? Hold on. If I'm right, I'm gonna be... I'm awesome if I'm right. Tourism rules of resonance. What this means, you may recall, is that the negative charge on an acidic ion is not located on one oxygen, or rather, or the other, is rather shared between the two. I am right! Oh my goodness, I am so cool, handsome, funny, and intelligent. Wait, speaking of... and so... Let me just check one thing real quick. Miracles of a poor man's dream. Yeah, that sounds something like what Sadie would say. At least that should sound like something like what... Fudge, what's wrong with me? I guess stroke. Called the bombulance. There. I thought on Saddam Hussein. I don't know him. I don't play football, so I'm not a huge soccer fan. And now it's time to think about back that statement from the previous section that was so important that we got to print in bold font in some paragraph. Say it again. Electrostatic charges when they're positive, negative, more stable. Yeah. Okay. Simple. While the electron lone pair stuck in one place, lone pair because of resonance. Isn't the way to think about it. The lone pair on amide and nitrogen is not bonding with a proton. Okay, I feel like... Oh, there's another effect. Why there are so many effects? Can you just... I mean, we get it. We get it. Like, the more chill... The more chill an acid is with having an extra electron, the better the more acidic it is. Gave us of acidic mono, D, and 3 chlorinated derivatives. The more chlorine you add, the more acidic they get. Presence of chlorine clearly indicates the acidity of the carboxylic acid group, but the argument here does not have to do with reason to consideration because no additional consideration can be drawn. Rather, the explanation for this phenomenon involves something called the inductive effect. A chlorine atom is more electronegative than hydrogen, and thus is able to induce or pull electron density towards itself away from the carboxylate group. In effect, the chlorine atoms are helping to further spread out the electron density of the conjugate base. Stabilizing effect. In this concept, the chlorine is called electron withdrawing group. Wait, hold on, the other picture too. That's this one. Here the electrons are delocalized between two atoms. From former Yugoslavia. I don't know where that was. I don't know where that is. That's so... I'm not good with geography. 2 oxygen. Has Danny masters like Stalin? He's them. But I thought I knew they saying I don't know basketball players though that well. Okay, so between 2 oxygen atoms, leading to more acidic acid because higher stability. Then the next one, which is this one, which is here, chlorine is pulling electrons away, leading to higher stability, more acidic with more chlorine. Alright. Make us bad maths. I am awful. I know maths. Oh, that's it. That's cool. Oh, resonance effects are more powerful than inductive effects. Alright. Hold on. Back then, that's important. To clone the chant of useless measures for. So yeah, I'm awful at maths. Oh, okay. So, resonance effects are more powerful than inductive effects. Resonance sharing more powerful than inductive, which is. Alright, cool. Common acids and bases, cool. Let's go on. Because you got French person acid directive for math. Oh, okay, and then we got the table. So acids, makes sense. Notable mentions. Aspirin. Can't remember between 30 minutes. We're really moving like crazy. First discovered and isolated from human. Well, that's interesting. Then without they exist, since I retrace a body introduction, carboxylate containing 20 carbon. Why are we learning about random thing? I don't know if people went. I haven't really seen that goober in a long time. People left. Because the biggest French hater. I don't know. I don't know. I just feel like human rights should be left for the humans, not the French. They're wasting them. Prostaglandins are unsaturated carboxylic acids consisting of a 20 carbon skeleton, also contains 5 member ring. They are biochemically synthesized from fatty acids. Acid, the CD graphic on the left, the unique shape. That's a bond, but the unique shape of acid caused by a series of double bonds helps to put it into position to make a 5 member ring. Neat. Oh, we can actually read this now, which is pretty fun. When I imagine that people, I'm tired for this year. Bye, JZ. That is absolutely fair. I feel like we're all too tired. What kind of game she? Consisting of a 20 carbon skeleton, also contains 5 member ring and basically fast as the yeah. Why are we learning about aspirin? That's such a random thing, just throwing in the middle. Yeah, so like acids and like giving away electrons. Here's aspirin for. That's, I don't know. I gotta do my homework. Let's see a head start then. Niggas chat's insane. Only sometimes. Last live stream was great. And that's it. Oh, Lewis theory. Oh, great. Now we have that Lewis fella. Function groups, C function groups, and aspirin. Is that important? Because I don't want to. I am disgusted by them. They eat snails for fun, not to build poison resistance. Yeah. You divided by 4 is united by this one stream. That's what I'm all about. Ah, okay. Oh, this is actually surprisingly short. I love it. Okay, Lewis fella. According to Lewis theory, an acid is an electron pairwise acceptor. And according to Lewis, acid is an electron pair acceptor, and a base is an electron pair donor. Hold on now, but wouldn't this? So are they sharing protons or electrons? Don't you sound French? Yo! Happy, chill! Whoa, happy! Listen, I get that arguments can sometimes get heated, but don't insult people like that, okay? Whoa, happy, wow. He's still human. Alright? Anyhow, those bases are also called bronze bases. However, many of those acids are not bronze acids. This is so... Is the you know what? Has nothing to do with acids. Has nothing to do with this definition. But I love this sentence. It's like chill. Which may be stable common molecule. As shown the top point, drawing common bond for the rose base. Yeah, in which formal charge of bond is negative and that of phosphorus is positive. And this complex bond acquires new and valence configuration of phosphorus and argon configuration substituents. On these atoms are not large, complex equilibrium. Ah, jeez. It's gonna be fun. Yeah, I'm gonna buy. Bro, would you make it? Yeah, they have them. I actually wonder, you know what, let me check. What are these stats? Last time I checked was something like 2%. What's the percentage now when it comes to male to female to other ratio? Let's see. Audience. Where is it? Gender. Male 96, female 3.5. Cool. Thick. I didn't find the prime on prawns of room, bro. Mate, that joke is from like 2016. No, wait, way earlier than that. That joke is from like 2012. It's been over a decade. Snails for fun is French, speaking French. Hold on. What is this definition? Okay. So we have Lewis acid, Lewis base. And when they get together, it's just donating. Oh! Definition. That's a phenomenal graphic. Basically this. That's a phenomenal graphic. I don't feel bad. I don't feel too bad about stealing these graphics because this is for me. These notes are for me. So for the video, I'm actually gonna make my own. Okay. So we have acids with base. This. No. Electron deficient aluminum atom bonds to covalent chlorine atom by sharing one of its unbonding bonds. Electron pairs that achieves Nagon-like valence are locked. Chlorine principle electrons. Both the aluminum and the chlorine have formal charges as shown. In the carbon-chlorine bond, it becomes raised with the bond of the electron against atom. Cool. The carbon assumes positive charge. We refer to such carbon species as carbocations. Carbocations are Lewis acids, as the reverse reaction demonstrates. So, carbocations carbon chlorine bond is going to. The carbon assumes a positive charge. Okay. I am. Common option Lewis base donated per production of the magnesium cation Lewis acid. Alright. Jeez, this is bloody awful. Are all the parts of the world that different? Not really. I mean, depends. You mean like all the? You mean like people? You mean like places? You mean like? There's definition focused on the range structure will be on the acid-base reaction of the type. Okay. So we have Lewis, electrons shared, and Lowry, protons shared. Now on to function. There's a lot of incest going on. What? When? Happy? Happy? Wanna explain yourself? Happy, but you have a habit of deleting messages, so... Hold on. I don't know, maybe once you just commented out and then deleted it right away. I don't... This is my last message. Sorry, make it just... Anyone who eats snails for fun is French or close to being French. That's your last message. Unless you mean like... No. Yeah, that's your last message. After that, I don't see a single message. I can give you a screenshot if you want. That is your last message. That's your last message. It's before day 9. This is your last message. Unless like it got auto deleted because you said something spicy. Happy, listen, here you can see the screenshot of what I see. Tell me which one. On my screen, yeah. Then I think YouTube just deleted them. I think this guy's probably happy. That's please don't. I have a family feed. Functional groups are not mine, but you know, someone's. Functional groups are atoms or small groups of atoms, 2 or 4, that exhibit a characteristic reactivity when treated with certain reagents. A liquid functional group will almost always display its characteristic chemical behavior when it's present in a compound. What do you mean characteristic? Because characteristic doesn't really mean large or small, it means characteristic. A characteristic names that often carry over in naming individual compounds. Following table. In the following table, the atoms... There is no table. In the following table, the atoms of each functional group are colored red, and because the nomenclature suffix denotes them. Some but not all function groups also colored. You mean like table in the next chapter? Oh yes, it is. Okay. So we have alkene. Okay, so alkene is ethane. I love the fact that there are like 3 separate ways to name something. That's not gonna be confusing at all! What a phenomenal idea. Hi the ninja. Welcome. I am so glad there are 3 different ways to name things. I'm not even gonna try to remember all that. Okay. Ah, this is a long chapter. Fun. Hold on, let me... oops, this what I meant. Can I send a message on Discord? I don't know, if you want to. So, we have this now, which is intermolecular forces. Forces between molecules, if I'm guessing correctly. It's not about, I don't know, Happy, you've sent a lot of wild things in the past. The properties of liquids are intermediate between those of gases and solids, but are more similar to solids, in contrast to intermolecular forces, such as covalent bonds that hold atoms together. In molecules and polyatomic ions, intermolecular forces hold molecules together in a liquid or solid. Okay, yeah, makes sense. Intermolecular. Okay, intermolecular forces are generally much weaker than covalent bonds, because further apart. For example, it requires 927 kilojoules to overcome the intermolecular forces and break both OH bonds in 1 mole of water, but it takes only about 41 kilojoules to overcome the intermolecular attractions and convert 1 mole of liquid water to water vapor at 100 degrees Celsius. By a similar value, the intermolecular forces in liquid water are among the strongest such forces known. Cycloethers. As the complex nomenclature gets a lot worse. That's not reassuring at all, though. I don't... Why does the organic chemistry just get progressively worse? It's the opposite from everything we've studied so far. With everything we've studied so far, it starts off pretty bad, but then it gets better. Slowly but surely it gets better. Organic chemistry is the only one which gets worse and worse. Alright, it's fine though. We can make it happen. The properties of liquids and yeah. I'm really tired though. It's been 50 minutes. Okay, the organic chemistry lessons are going to be shorter because I just can't deal with it for such a long time. We're on the third sub-chapter though, so we're getting really far. Really, really far. Oh, this is painful. This is really painful. And slow. Well then, I feel like for now that'll be it. I'm feeling really tired after this stream. Really, really tired. So, I guess that'll be it for today's live stream. I know it was a short one, but I can't. We got through acids at least, so that's pretty good. Anyhow, I suppose for now that'll be it. Thank you everyone so much for watching, and have a great day. Bye.